So yesterday we discussed about RDD, right? So and I have also given you some tasks to do. Did you try those tasks? So if you are facing any problems trying those tasks, then I'll send the solutions also. So if you want any clarifications, you can view that and you can get it clarified. So by the end of the day, I'll send the solutions as well. Okay, for every day I'll be sending you the tasks. So the next day will be the solutions. Okay. So just try all those simple tasks. So they are not so much big tasks. They are just simple tasks. You can just try it out. Okay. Fine. So let's start with today's class. Sharing my screen. You joined? Okay. Let's continue. So in the last class we discussed about all the RDD transformations, RDD actions, right? So let us continue today with the data frames. Okay, data frames you have already created, right? In NumPy pandas you have used everything. You have created the data frames, you have displayed the data frames, right? The same thing you are doing here also. Okay, there is nothing different, but here the way how you are going to create the data frame is different. That's it. Here also you are creating the data frames itself. Okay, so what is basically a data frame? A data frame is nothing but it is a table like structure. Okay, so it is consisting of what? Rows and columns. Okay, but in pandas you have used the data frames, right? So that was for only small amount of data. So here this is for the big amount of data. Okay, here also you are using the data frames only. So the basic reasons why we are preferring data frames is that it is having optimized execution, it is having built-in functions, okay, it is having SQL query support, and most commonly used in Pyspark API. So it is also providing you the SQL query support. You can execute the SQL queries also with the data frames. Okay, so such a powerful data frames Pyspark is giving you. Okay, so when you compare these data frames with the data frames what you are creating in pandas, okay, when you compare these two, pandas data frames are only for small data and for the local data. Okay, but this PySpark data frame is for the distributed system and for the big data. Okay, and Pandas API used to run in only single machine. Pyspark API, these data frames will be running in the cluster scale or the distributed environment. Okay, so these are the difference between normal data frames and Pyspark data frames. Okay, so that is the data frames what you were using with the pandas and now what you are using with the Pyspark. So these are the differences. How do you create a data frames in Pyspark? So creating the data frames in pandas you know already, but here you should know how to create the data frame in Pyspark. So here we can create the data frames in three methods. Okay, you have three methods. One is from the Python list. See here I have created the data John with the age 25, Sarah with the age 30. So this is my raw data, and from this data I am creating the data frame. How I am creating the data frame? With the help of Spark object, spark dot create data frame. Okay, which is the function you are using? Create data frame. So this function you are using to create the data frame. What parameters it will take? It will take the data what you have created and it will take the column names. Okay, so what is this John? It is the name. What is this 25, 30? These are the ages, right? So the column names you have to provide here. So your create data frame function will take two parameters. One is data, that is the raw data what you are given, and the one more parameter is column name. How many data you have? those many column names you have to give. Suppose you have one more column, name, age and city. Okay, so here you have to specify name comma age comma city. Okay, so here you have to give John 25 Bangalore, Sara 30 Davangere, like this. Okay, so like this you are going to create a data frame from this raw data. This is one method, first method. Second method, you can also create the data frame from RDD. So RDD we have discussed yesterday, how to create the RDD data, how to print the RDD data. Okay, so here from the RDD we are creating the data frame. So this line we know already, spark context dot parallelize. We have used it yesterday. Inside this you are going to pass the data. 1 apple, 2 banana. This is the ID number and fruit name. Okay. Next what you are doing, spark dot create data frame. Here also you are using the same function, create data frame only. But the parameters what you are passing is, here you are passing RDD along with the ID and fruit. So there you had name and age, here you are having ID and fruit. Okay, the method, the function what you are using is same. Okay, either from Python list or from the RDD. So here one line you have to add, that is spark dot context parallelize. Okay, so using this line it is creating your RDD. From the RDD you are creating the data frame. Okay, this is the second method. Third method is from the external CSV file. Suppose you have a CSV file, in that you have a data. Okay, so that you can use read that. Okay, df is equal to spark dot read dot csv. So inside that you have to give your CSV file name. These two parameters, header is equal to true means what? The first row in your data file, that is data.csv is your file. In that file whatever is the first row, that will be your header. That means that will be your column name if header is equal to true. Okay, and infer schema is equal to true we are having. So this parameter specifies that, so whatever the things, the data your data.csv file is having, so that changes what you are doing will be affected to the data. Okay, so these are the three methods from which you can create the what data frames, from the Python list, from RDD, from the external CSV file. So you can just give data.csv, that is also fine. You need not give header is equal to true infer schema, that you can skip, that is optional. Okay, so these are the three methods. Join the online class. Okay, so next, now coming to the schema. So when you studied the database, there you have a schema, right? So schema is nothing but what? Structure of your data frame. So what is the structure of your data frame? How it looks like? Okay. So if you want to view the schema, then you can give df.print schema. So it will give you all the details about that data frame. Okay. df.print schema. So entire schema of this data frame will be printed. Then if you just want to see the data types, what your data frame is having, you can give print df.d types. Okay, d types will give you the data types. Okay, then so if you want, you can also create the schema manually. So this is like optional. If you want, you can create it. Otherwise, you can directly get it from the CSV file. Okay, if at all, if you want to define your schema manually, this is the method. Okay, so from the Pyspark SQL type, you are importing what? Struct type, struct field, string type, integer type. So whatever you require, that everything you want to import, so just import it. And here, if you remember structures in C, so it is similar to that structures. Okay, so schema is equal to struct type. So what is the type of your structure? So here I have two fields. One is name, other one is age. Name is of string, age is of integer. So these are what? Structure fields. So with the help of struct field, we are defining the fields. And then finally, we are creating the data frame by passing data and schema. Okay, so this is how you are defining the schema manually. how to display and select the columns. Your data frame is having columns, right? So if you want to view the entire data frame, what you can do, df.show. df.show will display you the entire data frame. For example, if you want to display, if you want to see only one column, then what you can give, df.select, give the name of that column dot show. Suppose I want to see only the name column, then what I can give, df.select name column dot show. So if you want to see age column, specify age column show. Okay, then you can also select the multiple columns. So df.select, specify how many columns you want, then followed by that dot show. Okay, then you can also use the expressions. Okay, suppose say I have the age column, to all the age values I want to add plus 10. So how I can do it, df.select, in that select the age, df.age plus 10, how much you want to add, you can add dot show. Means modifying, I am modifying what, the column values. Okay, I am not just displaying here, I am modifying the column values. Whatever the age values I am having in the age column, to all the values I am adding plus 10. So not only age, you can take any column and you can modify it by giving the expression. You can subtract minus 10 from the age, you can multiply, you can do any kind of expressions there. Okay, so this will be applied to all the entire column. Everybody's age will be incremented by 10. Okay, so this is how you are using expressions. Okay, how to show all data, how to select the single column, how to select the multiple columns, and how to use the expressions in columns. So these are the things. Then you can also filter. You can also filter based on some conditions. Okay, so here we are using what, mainly two functions, filter or where. Okay, based on the condition. Let us say I want to filter the age column which is having greater than 25. So how I can do, df.filter, df.age is greater than 25. So I want only these kind of values. So I can give the condition followed by that dot show. Okay, this is how I am filtering. Then you can also filter based on multiple conditions. So here I gave only one condition, that is age is greater than 25. Now okay, so here I can give multiple conditions. Okay, so one is age is greater than 25 and name should be Sarah. So two conditions, any n number of conditions you can give, but that should be joined with AND operator. Okay, and finally dot show. Okay, then you can also give SQL like string syntax. For example, df.filter, it is just you are mentioning the condition age is greater than 25 inside the double quote. See the difference. So for filtering the rows, what you are taking, df.age greater than 25. So here what you are taking, just age is greater than 25. So here you are using double quotes, there you are not using double quotes. Okay, so here this is a SQL like string syntax. Okay, so in SQL you will be providing the conditions, right? The same thing here you are giving, not based on the data frame. Okay, so here also like this also you can give, but you don't get confused about this SQL like string syntax. You just go with the these normal things only, df.age, df.age, df.name, like this. Okay, you can also modify the data frame structure. Okay, you can add a new column, you can drop a existing column, you can rename the column. Okay, how do you add the new column? Suppose I want to add a new column, the name of the column is age plus 5. Okay, how I can do it, df dot with column age plus 5. So in this new column what I am giving, df dot age plus 5. Understood? Here I am adding what, new column. What is the name of the new column? Age plus 5. In that column what I am displaying, what I am adding actually, df dot age plus 5. So age column is already there, okay, but I want to add a new column. The name of the new column is age plus 5. There what values I am giving? The normal age values plus 5. Okay, so this is new column I created. And if you want, you can drop that column. How do you drop it? Df dot drop, give the column name. So this column will be dropped. Okay, then you can also rename that column. So for example, I don't want it to be age, I want it to be years. Then what you can do? Df dot with column renamed. So with column will add a new column, with column renamed will rename your existing column. Okay, so my column name was age, now I am changing it to years. Okay, with the help of the function with column renamed. Okay, now if your data frame is having missing values, how do you handle the missing values? So you know already how to handle the missing values in pandas, right? So here also same thing, df dot na dot drop. What it will do? It will drop the rows which are having the null values. Then finally dot show. So after dropping, you show me what is the final result. Okay. So dropping the rows with null values. Okay. df dot na drop. Okay. So this is how you drop the null rows with null values. Then you can also fill the missing values. For example, somewhere age is having some blank data and name is also having some blank data. So what I am doing? I am filling those with 0 and unknown. Wherever empty is there for age, I am filling 0. Wherever the name is empty, I am filling there with unknown. Okay, this is how you fill the missing values. Okay, so df dot na dot fill, this is how you are filling. Okay, finally you are showing after filling age with 0 and name with unknown, wherever there are empty places you can see the data frame. Okay, then you can also replace it with some specific values. Okay, for example, your data frame is having NA. Somewhere it is having NA. I don't want this NA. So instead of NA, what I have to give? None. So I can replace NA with none. Okay, wherever there is NA, I am putting as none. Okay, this is replacing. You can drop the rows with null values, you can fill the missing values, you can replace the values. Okay, just like pandas. Pandas ಅಲ್ಲಿ ಏನು ಮಾಡ್ತಿದ್ದೀರಾ, ಇಲ್ಲೂ ಅದನ್ನೇ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಸೇಮ್ ಥಿಂಗ್. Okay, but what is the difference? Functions what you are using, the format, ಅದು ನಿಮಗೆ ಡಿಫರ್ ಆಗುತ್ತೆ ಅಷ್ಟೇ. So concepts you know already, how to find the missing values, how to fill it, how to replace it, everything you know, but the same thing only here you are repeating. But here you are handling what? You are handling with the Spark, right? So that's why. You can also use order by. SQL ಅಲ್ಲಿ order by use ಮಾಡಿದ್ರಲ್ವಾ, you have used order by. So you can use order by, okay, to arrange the values. Okay, so if I give df dot order by age, my age column will be arranged in the ascending order. Okay, dot show, so after arranging it, show it. Okay, so if you want to arrange it by descending, you have to explicitly specify. Ascending is done default. Okay, so if you give order by default it will arrange in the ascending order, but if you want to arrange it in descending order, what you have to give? You have to specify it. Okay, df dot order by, so inside that what you have to specify? Age in descending order, df dot age dot descending. Okay, and you can also sort multiple columns. Okay, df dot order by department salary show, that means arrange the department in ascending order, arrange the salary also in ascending order. At a time we are doing, either you can do it for the single or you can do it for the multiple columns. Okay, so for descending you have to explicitly specify, otherwise it will not do, it will only do the ascending only. Okay, then You can use group by, okay, so group by department, okay, so take the department and group according to the department. So aggregation, salary and average, so average of the salary. So here you are having multiple aggregations also. You are grouping it by department, okay, and aggregating it with average salary, and for that you are creating the alias and you are also counting that with the alias. So now don't worry about this, it is just a one feature, okay. You can just use group by and aggregations. If you have used group by and aggregations in SQL, so here it will become easy for you. So there are so many aggregate functions, you see, count, sum, average, min, max. You can just make use of this aggregation functions. So if you want to count anything, use count. If you want to do sum, you can use sum, average, minimum, max. You can use any of these things. So group by basically groups your data according to what you will give. So here I have given salary, average of the salary. According to the average of the salary, your department will be grouped. Okay. So joins we will take up later. Okay. So up to this, it is fine. I'll give you the task. Yesterday's task, have you tried? Did you try yesterday's task?